The atmosphere is the thin layer of gases that surrounds the Earth and is held in place by gravity. It extends from the surface of the Earth to an altitude of about 10,000 kilometers, 6,200 miles. The atmosphere plays a crucial role in supporting life on Earth, as it protects us from harmful solar radiation and meteoroids, and it also provides the air we breathe. Composition of the atmosphere. The Earth's atmosphere is composed of various gases, with nitrogen, 78%, and oxygen, 21%, making up the majority of the atmosphere. The remaining 1% is made up of trace gases, including argon, 0.9%, carbon dioxide, 0.04%, neon, 0.0018%, helium, 0.0005%, methane, 0.00017%, and hydrogen, 0.00005%. Water vapor is also present in the atmosphere, but its concentration varies depending on location and weather conditions. Layers of the atmosphere. The atmosphere can be divided into 5 layers based on temperature changes with altitude. These layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Troposphere. The troposphere is the layer closest to the Earth's surface, extending from the surface up to an altitude of about 7 to 17 kilometers, 4 to 11 miles, depending on location. This layer is where all weather occurs and where humans live and breathe. Temperature decreases with altitude in the troposphere, making the lower regions warmer than the upper regions. The troposphere contains about 80% of the atmosphere's mass. Common examples of the troposphere include clouds, precipitation, and winds. Airplanes fly in the troposphere as well. Stratosphere. The stratosphere lies above the troposphere and extends up to about 50 kilometers, 31 miles, above the Earth's surface. In the stratosphere, the temperature increases with altitude, due to the absorption of ultraviolet radiation by ozone. The ozone layer in the stratosphere absorbs most of the sun's harmful ultraviolet radiation, making this layer important for protecting life on Earth. Common examples of the stratosphere include the ozone layer, which shields us from harmful ultraviolet radiation. Mesosphere. The mesosphere is the third layer of the atmosphere, lying above the stratosphere and extending up to about 85 kilometers, 53 miles, above the Earth's surface. In this layer, temperature decreases with altitude, making it the coldest layer of the atmosphere. The mesosphere is also where most meteoroids burn up upon entering the Earth's atmosphere. Common examples of the mesosphere include noctilucent clouds, which are clouds that form in the mesosphere and are visible from the ground. Thermosphere. The thermosphere is the fourth layer of the atmosphere, extending from about 85 kilometers, 53 miles, up to 600 kilometers, 370 miles, above the Earth's surface. In the thermosphere, temperature increases with altitude, due to absorption of solar radiation. This layer also contains the ionosphere, where the atmosphere is ionized by solar radiation, creating the auroras and allowing for radio communication. Common examples of the thermosphere include the auroras, also known as the northern and southern lights, and communication via radio waves. Exosphere. The exosphere is the outermost layer of the atmosphere, extending from about 600 kilometers, 370 miles, up to about 10,000 kilometers, 6,200 miles, above the Earth's surface. The exosphere is very thin, with very low density and pressure. This is the layer where satellites orbit the Earth, and it gradually merges into interplanetary space. Common examples of the exosphere include satellites and space debris. In summary, the Earth's atmosphere is a complex system made up of various gases and layers. Each layer of the atmosphere has its own unique properties and plays a crucial role in supporting life on Earth. From the troposphere, where we live and breathe, to the exosphere, where satellites and space debris orbit, the atmosphere is a fascinating and important part of our planet. It's also worth noting that the composition and properties of the atmosphere can vary depending on location and time of year. For example, the atmosphere in urban areas may contain higher levels of air pollution due to human activities, while the atmosphere in remote areas may be cleaner and more pristine. Additionally, the atmosphere can change over time due to natural phenomena such as volcanic eruptions or human activities such as burning fossil fuels. Understanding the Earth's atmosphere and its various layers is important not only for understanding our planet but also for addressing important environmental issues such as climate change and air pollution.
Air pollutants are substances or particles present in the air that have harmful effects on human health, animals, plants, and the environment. These pollutants can come from both human and natural sources and can have both short-term and long-term effects on our health and the environment. Here are some of the most common air pollutants, along with their sources, properties, and harmful effects. Carbon monoxide, CO. Carbon monoxide is a colorless, odorless gas that is produced when fossil fuels, such as gasoline, diesel, and natural gas, are burned. It is a poisonous gas that can cause headaches, dizziness, weakness, nausea, confusion, and even death at high concentrations. CO binds to hemoglobin in the blood, reducing the amount of oxygen that can be carried to the body's tissues. This can lead to tissue damage, especially in the heart and brain. CO is produced by incomplete combustion of fossil fuels, such as in vehicles and industrial processes. Nitrogen oxides, NOx. Nitrogen oxides are a group of gases that are formed when nitrogen and oxygen are exposed to high temperatures, such as in combustion engines, power plants, and industrial processes. Nitrogen monoxide, NO, and nitrogen dioxide, NO2, are the most common forms of NOx. They can cause respiratory problems, especially in people with asthma or other pre-existing lung conditions. They can also react with other compounds in the atmosphere to form acid rain, which can damage buildings, plants, and aquatic ecosystems. NOx is primarily emitted from vehicles and industrial processes. Sulfur dioxide, SO2. Sulfur dioxide is a gas that is produced when sulfur-containing fuels, such as coal and oil, are burned. It can cause respiratory problems, including bronchitis and asthma, and can contribute to the formation of acid rain. SO2 can also cause damage to plants and materials, such as buildings and monuments. SO2 is primarily emitted from power plants, industrial processes, and ships. Particulate matter, PM. Particulate matter is a mixture of small particles and liquid droplets that are suspended in the air. It can cause respiratory problems, including asthma and lung cancer, and can also contribute to heart disease and stroke. PM can come from a variety of sources, including vehicles, industrial processes, construction sites, and natural sources like dust and wildfires. PM is categorized based on its size. PM10, particles less than 10 micrometers in diameter, and PM2.5, particles less than 2.5 micrometers in diameter. Ozone, O3. Ozone is a gas that is formed when nitrogen oxides and volatile organic compounds, VOCs, react in the presence of sunlight. It can cause respiratory problems, including asthma and bronchitis, and can also damage crops and forests. Ozone is primarily formed in urban areas and can be worsened by hot and sunny weather. It is typically found at ground level in urban areas and can be transported over long distances by wind. Volatile organic compounds, VOCs. VOCs are a group of chemicals that include benzene, toluene, and formaldehyde. They are emitted from a variety of sources, including vehicles, industrial processes, and consumer products like paints and solvents. VOCs can cause respiratory problems, including asthma and bronchitis, and can contribute to the formation of smog. Some VOCs are also carcinogenic, meaning they can cause cancer with prolonged exposure. In conclusion, air pollution is a significant environmental problem that has harmful effects on human health and the environment. By understanding the sources and properties of air pollutants, we can take steps to reduce our exposure and improve air quality. This can include reducing emissions from vehicles and industrial processes, increasing energy efficiency, and using cleaner energy sources.
Acid rain. Acid rain is precipitation that is more acidic than normal rainwater. It is formed when sulfur dioxide and nitrogen oxides, which are primarily produced by the burning of fossil fuels, react with water vapor in the atmosphere. The resulting sulfuric acid and nitric acid can fall to the ground as acid rain, or they can mix with other pollutants to form particulate matter, which can be harmful to human health and the environment. Sources of sulfur dioxide and nitrogen oxides include coal-fired power plants, oil refineries, and transportation, particularly vehicles that burn gasoline or diesel fuel. Acid rain can have a number of harmful effects on the environment, including damage to vegetation. Acid rain can damage leaves, needles, and roots of plants, making them more vulnerable to disease, pests, and environmental stresses. This can lead to reduced growth, lower crop yields, and even plant death. Acidification of water. Acid rain can lower the pH of surface water and groundwater, making it more acidic. This can harm aquatic life, particularly fish, amphibians, and invertebrates, which are sensitive to changes in pH. Corrosion of buildings and infrastructure. Acid rain can corrode building materials, including metals, stone, and concrete. This can lead to damage to buildings, bridges, and other infrastructure. To reduce the impact of acid rain, it is important to reduce emissions of sulfur dioxide and nitrogen oxides. This can be achieved through a combination of regulatory measures, such as requiring power plants and other industrial sources to install pollution control equipment, and voluntary measures, such as encouraging the use of clean energy sources and promoting energy efficiency. Greenhouse effect. The greenhouse effect is a natural process that occurs when certain gases, such as carbon dioxide, methane, and water vapor, trap heat in the Earth's atmosphere. This helps to regulate the Earth's temperature, keeping it warm enough to support life. However, human activities, such as burning fossil fuels and deforestation, have increased the concentration of greenhouse gases in the atmosphere, leading to a phenomenon known as anthropogenic climate change. The greenhouse effect is important for life on Earth, but an increase in greenhouse gases can lead to a number of harmful effects, including rising temperatures. The Earth's average surface temperature has increased by about 1 degree Celsius, 1.8 degrees Fahrenheit, since the Industrial Revolution, and is projected to continue to rise. This can lead to more frequent and severe heat waves, droughts, and wildfires, among other impacts. Melting of ice. As temperatures rise, glaciers and ice sheets are melting at an accelerated rate, leading to rising sea levels. This can have serious consequences for coastal communities and infrastructure. Changes in weather patterns. Climate change is causing changes in precipitation patterns, including more frequent and severe droughts and floods. This can lead to water shortages, crop failures, and other impacts on human and natural systems. To reduce the impact of the greenhouse effect, it is important to reduce greenhouse gas emissions. This can be achieved through a combination of policies, such as carbon pricing, subsidies for renewable energy, and regulations on emissions from power plants and other industrial sources. Global warming. Global warming refers to the long-term increase in the Earth's average surface temperature, which is primarily caused by human activities that increase greenhouse gas emissions. The effects of global warming are similar to those of the greenhouse effect, including rising temperatures, melting of ice, and changes in weather patterns. Some of the potential impacts of global warming include disruption of ecosystems. As temperatures rise, many species may be forced to migrate to new areas, disrupting ecosystems and potentially causing extinctions. Health impacts. Rising temperatures can increase the incidence of heat-related illnesses and deaths, as well as the spread of disease-carrying insects and other vectors. Economic impacts. Global warming can lead to increased costs from natural disasters, such as floods and hurricanes, as well as reduced productivity in certain industries, such as agriculture and tourism. To reduce the impact of global warming, it is important to reduce greenhouse gas emissions, as mentioned earlier. In addition, adaptation measures can be taken to help communities and ecosystems adapt to the changes that are already happening or are likely to occur in the future. This can include measures such as improving water management, developing heat-resistant crops, and building infrastructure that can withstand more extreme weather events. Overall, addressing these issues will require a combination of global cooperation, innovative technologies, and sustained efforts to reduce emissions and build resilience. The ozone layer is a naturally occurring layer of gas in the Earth's upper atmosphere, primarily composed of ozone molecules, O3. It is located in the stratosphere, between 10 and 50 kilometers above the Earth's surface. The ozone layer plays a vital role in protecting the Earth from the harmful ultraviolet, UV, radiation emitted by the Sun. Importance of the ozone layer. 1. The ozone layer absorbs most of the harmful UV radiation from the Sun, protecting life on Earth from its damaging effects. 2. UV radiation can cause skin cancer and cataracts, weaken the immune system, and affect plant growth and crop yields. 3. The ozone layer helps regulate the Earth's temperature and climate by absorbing and reflecting some of the Sun's radiation. Depletion of the ozone layer. 1. Ozone depletion refers to the gradual thinning of the ozone layer, primarily caused by the release of human-made chemicals, such as chlorofluorocarbons, CFCs, halogens, and other halogenated substances. 2. When these chemicals are released into the atmosphere, they eventually reach the stratosphere, where they react with ozone molecules, breaking them down into oxygen molecules, O2, and preventing them from absorbing UV radiation. 3. The release of these chemicals has caused a significant reduction in the amount of ozone in the Earth's atmosphere, leading to a hole in the ozone layer over Antarctica. Causes of ozone depletion. 1. Human-made chemicals, chlorofluorocarbons, CFCs, halogens, and other halogenated substances are the primary causes of ozone depletion. 1. These chemicals are found in refrigerants, aerosols, solvents, and foam-blowing agents. 2. Natural causes. Volcanic eruptions can release gases like chlorine and bromine into the atmosphere, which can contribute to ozone depletion. Effects of ozone depletion. 1. Increased UV radiation exposure. UV radiation can cause skin cancer, cataracts, and other health issues, as well as weaken the immune system. 2. Reduced crop yields. Ozone depletion can affect plant growth and reduce crop yields, leading to decreased food production. 3. Disruption of marine ecosystems. Ozone depletion can have significant impacts on marine ecosystems, affecting fish and other marine organisms. 4. Changes in weather patterns. Ozone depletion can cause changes in weather patterns, leading to more extreme weather events like storms, floods, and droughts. Preventive measures. 1. The Montreal Protocol, an international agreement signed in 1987 to reduce and eventually eliminate the production and use of ozone-depleting substances. 2. Use of alternative chemicals, replacing the use of CFCs with less harmful chemicals such as hydrofluorocarbons, HFCs, hydrochlorofluorocarbons, HCFCs, and other alternative chemicals. 3. Energy efficiency, encouraging energy efficiency to reduce emissions and energy consumption, as well as using renewable energy sources. 4. Consumer awareness, encouraging individuals to use products that are ozone-friendly, such as appliances that are labeled ozone-friendly or ozone-safe. In conclusion, the ozone layer is essential for the protection of life on Earth from the harmful effects of UV radiation. Ozone depletion is primarily caused by human-made chemicals and can have severe impacts on human health, agriculture, and the environment. Preventive measures such as the Montreal Protocol, use of alternative chemicals, energy efficiency, and consumer awareness are critical to prevent further depletion of the ozone layer and ensure a healthy and sustainable future for the planet.